We are solving numerical problem related to the chapter 4 of class 10, and it will be helpful to the students who are preparing for the SEE examination. Okay, now I want to do today another numerical problem. Look at this. If an object at a distance 6.4 into 10 power 6 meter from the center of the earth weighs 10 Newton, what will be its weight if it is shifted to a distance 1.28 into 10 to the power 7 meter from the center? Now I want to make you clear about this numerical. It is divided into two parts. Look at this is if earth. Then the first part says that from the center to a distance of how much? 6.4 into 10 to the power 6 meter. Let's say this is the distance. So first distance, which can be denoted by d1. At this distance, that body weighs 10 Newton. 10 Newton means the force with which this earth attracts this body with 10 Newton force. Now, now the same is taken to very height. Let's say the height is what? 1.28 into 10 to the power 7 from the center. From center to 1.28 into 10 to the power 7 meter means at this height. Now, how much is the weight of that body? I mean to say the gravitational force of that body. This is the numerical. The whole distance is, let's say d2. d2 is whole distance. And d1 is distance from center to this point where it weighs 10 Newton. There are two cases. F1, d1 in one case, F2, d2 in another case. Now I want to convert it into a mathematical form. Look at this. First case, what is there? In first case, distance is given. We can represent it by d1, what I told you just now. d1 equal to 6.4 into 10 to the power 6 meter. And at this distance, weight is 10 Newton. Weight force F1 is equal to 10 Newton. This is first case. Now we can see we have one equation we can use. This equation can be used, but instead of using R, we are using distance D because there are two distances. That's why we have F is equal to capital G, capital M, small m by D square, and this is equal to F is 10. I'm not writing unit, later we'll write in answer, and I'm not writing this value just now because all the values are not given. This is d1 square. d1 is how much? 6.4 into 10 to the power 6 and 6 square. Now we cannot go any more to solve this numerical problem. Let's say this is equation number 1. This is equation number 1. Now we have second case also. Second case. In second case, what we have? Distance is given d2. It is given how much? 1.28. d2 is equal to 1.28 into 10 to the power 7 meter. And how much is the weight of that body or gravitational force on that body? F2 at this distance is the question. Now again we have to go through the same. We have F2 is equal to capital G, capital M, small m by d2 square. Now F2 not given, that's why I'm writing F2 only, and G, M, small m not given. D2 is given 1.28 into 10 to the power 7 and square of this. This is equation number 2. Now I want to compare this equation with each other. Look at this. We can divide one equation with another, and we have to find out F2. That's why I want to divide second equation by first one. That's why dividing equation 2 by 1 dividing equation 2 by 1, what we get? Left hand side divides left hand side. It means F2 is divided by 10. In the same way, right hand side, this should be divided by this. This is right hand side G, capital M, small m by 1.28 into 10 to the power 7 whole square. It is divided by capital G, capital M, small m by 6.4 into 10 to the power 6 whole square. Now this capital G, M, this capital G, they cancel each other. Now what is left? F2 by 10 is equal to, this goes up, 6.4 into 10 to the power 6 square upon 1.28 into 10 to the power 7 square. F2 by 10, this is equal to 6.4 into 10 to the power 6 divided by 1.28 into 10 to the power 7 whole square. Now I have to divide 6.4 into 6.4 by 1 by 28. 6.4 divided by 1.28. This is exactly fine. Now look at this, F2 by 10 is equal to 5 into 10 to the power 6. When this 10 to the power 7 goes up, it becomes 10 to the power minus 7, power becomes negative, whole square, or F2 by 10, this is equal to 5 into 10 to the power 6 minus 7 becomes minus 1 whole square, or F2 by 10, this is equal to 10 to the power minus 1 when it goes down, 10 to the power 1, 10 to the power 1, why should we write 1? I don't want to write 1, this 10 to the power 1 means 10, that's why this, okay. Now, or F2 by 10 is equal to, now look at this, 5 ones are 5, 5 twos are 10, 1 divided by 2 becomes 0.5, 0.5 square, isn't it? Or F2 by 10 is equal to 5 5 to 20, 25.25, or F2 is equal to 0.25 into 10. Therefore, F2 is equal to 2.5, and this is weight force. Force is measured in Newton. That's why this is our final answer. It means when a body which weighs 10 Newton at this point, 6.4 into 10 to the power 6 meter height, is taken to 1.28 into 10 to the power 7 meter height, then it weighs less, and it weighs how much? 2.5 Newton. This way we can solve the numerical problem.